This is problem 13.4 from the textbook. So if the 50 kilogram crate starts from rest and achieves a velocity of v equals 4 meters per second, when it travels a distance of 5 meters to the right, determine the magnitude of force P acting on the crate. The coefficient of kinetic friction between the crate and the ground is mu sub k equals 0.3. And we want to find, all right, so I've written out the problem here. So what we're going to do is we're just going to start with our free body diagram and kinetic diagrams. And so we'll do the crate. And we have that P force. We have the weight of the crate. We have the normal force of the crate. And a force of friction. We have this angle. And that's going to be, set that equal to the kinetic diagram. We have our G. And then we have our m times AX. So we can sum the forces in the x direction equals max. I'm just looking at that figure to do this. So we have negative force of friction. I guess I should have x and y just to indicate which is which. So negative F of friction plus P cosine of 30 degrees is going to equal max. So the force of friction is going to equal, so it's negative mu sub k times n plus P cosine of 30 degrees equals max. So we need n, we're looking for the, P is what we're looking for. We have mu sub k, we need n, and we need a sub x. And so to find a sub x, we can use that equation that v squared equals v naught squared plus 2a times s minus s naught, because they gave us the final velocity being 4 meters per second squared equals, and the initial velocity was 0, plus 2 a, and then s minus s naught is just the distance that it covers, so that's 5 meters. And so we get a equals basically 4 squared, so that's 16 divided by 10, so that's 1.6. And that would be meters, it's meter squared, or meters per second squared. So meters squared per second squared divided by meters, so you get meters per second squared. So we have that a sub x. We also need the n. To solve that, we can use our other equation. So sum of the forces in the y direction equals 0. So that's just looking back up the free body diagram and kinetic diagram. And so for the y direction, we have negative w plus n, then plus p sine of 30 degrees equals 0. And so we're going to get n equal to w minus p sine of 30 degrees. And w, I think they gave us the mass was 50 kilograms. So 50 kilograms times 9.81 meters per second squared minus p, which we don't know is what we're looking for, sine of 30 degrees. So now we have a value for n in terms of p. And I'm just going to write out that 50 times 9.81. Simplify it a little bit. So that's 490.5 newtons minus p sine of 30 degrees. So now we can put that AX and that N into that equation from above. So into that equation. So we get negative mu sub k, which mu sub k was 0.3. 0.3 times N, which is at 490.5 newtons, minus P sine of 30 degrees, plus P cosine of 30 degrees, equals, and the mass was 50 kilograms, just checking. 50 kilograms times A sub x, which we found to be 1.6 meters per second squared. So now we have everything except for the p's. So we can solve this out now. So we get negative 147.15 minus 0.3 times sine of 30 point, or minus, and then another minus, that's plus 0.15 p plus 0.866 p equals 50 times 1.6 was 80 newtons, and that was newtons also. So if we add that all up, we get we get 1.016 p equals 227. And so we get P equals to 223.6 newtons. And look back.